Many people are now using artificial intelligence sometimes without even realizing it. It is the magic behind the curtain that helps you write an email, that helps you find a specific photograph, that helps you get a quick answer to a complex question. It promises to make businesses more efficient and our daily lives easier. But while AI feels like it is everywhere, the fundamental tools to build it are not. A very small number of very large companies control most of the essential infrastructure. This concentration of power is critically important. It can reshape our economy, reshape the flow of information, and even reshape how democratic societies function. So who are these powerful players? Microsoft, Google, Amazon, Meta, Nvidia. They are more than familiar names, they've become the new gatekeepers of AI. At the very bottom of the entire AI revolution lies a piece of hardware, the graphics processing unit, or GPU. These chips were originally designed to render graphics for video games, but their architecture is perfectly suited for the parallel processing required by AI algorithms. And in the world of AI chips, one name stands above all others: NVIDIA. The company has achieved a level of market dominance that is almost unheard of in any industry. Experts estimate that NVIDIA controls somewhere between 80 and 95% of the market for the high-end GPUs necessary for training large AI models. This is not just a lead, it is a virtual monopoly on the single most critical resource for building cutting-edge AI. This dominance gives NVIDIA immense power to shape the direction of the entire industry. The company effectively decides who gets access to its latest and most powerful chips, and when. The biggest technology companies, with their vast financial resources and long-standing relationships with NVIDIA, are often first in line, able to pre-order tens of thousands of GPUs at a time. This allows them to build out massive data centers and gain a significant head start on training the next generation of AI models. Meanwhile, smaller startups, academic labs, and independent researchers are often left scrambling for the limited supply that remains. Once you have the chips, you need a place to put them and run them at an immense scale. This is where cloud computing comes in. For most companies, building and maintaining a massive climate-controlled data center filled with thousands of GPUs is simply not feasible. Instead, they rent computing power from a handful of giant cloud providers. This market, like the chip market, is highly concentrated. Amazon Web Services, Microsoft Azure, Google Cloud together control about 2/3 of global cloud infrastructure. They are the new landlords of the digital age, and the rent is steep. If you are a startup trying to train a large AI model, you have little choice but to turn to one of these three providers. They have the capital and relationships to buy NVIDIA's chips by the truckload and install them in massive server farms. They can set the prices, terms of service, and availability of this crucial resource. This means they are both the landlords and the competitors to the very companies renting their services. This creates a clear conflict of interest. A cloud provider could theoretically use its position to favor its own AI services or gain insights from the data of its tenants, giving it an unfair advantage in the market. At the heart of modern AI are foundation models. These are enormous neural networks trained on vast swathes of text and data from the internet. Training one of these models is astronomically expensive and resource-intensive. It can cost hundreds of millions of dollars, requiring tens of thousands of advanced GPUs, running for months on end. Because of these barriers to entry, creating a state-of-the-art foundation model is limited to a small exclusive club. Leading players include OpenAI, Google DeepMind, Anthropic, Meta. These models are the brains behind many AI apps. When you use a chatbot, a code-writing assistant, or an image generator, you're likely interacting with one of these foundational systems. The model creators, therefore, shape the information we get and the tasks AI can do. Biases in training data, editorial choices about what to include or exclude, and safety filters they implement all have downstream effects on millions. The high training cost means only the best funded can compete. Section 5. The invisible handshake. How money and boards connect the dots. The concentration of power in AI is not just a matter of a few companies dominating separate layers of the tech stack. The connections between these companies are deep and intertwined. Investments, board memberships, strategic partnerships. The major tech giants don't just compete, they fund startups. Microsoft's multi-billion-dollar investment in OpenAI, Amazon pouring billions into Anthropic, Google pouring billions into Anthropic. This makes supposed competitors financially and strategically aligned. Venture capital firms also play a crucial role. Andreessen Horowitz, Sequoia Capital, investments across dozens of AI companies, chip designers, and application developers. A portfolio of nominally independent companies share common investors with an interest in collective success. Investors can facilitate deals, share information, guide strategic direction, blurring lines and encouraging coordination. That's how the dots get connected. In a world where high-end GPUs are the most precious resource, the process of allocating them becomes a critical exercise of power. When demand far outstrips supply, NVIDIA, the major cloud providers, effectively become kingmakers. They decide who gets to build the future of AI, and who gets left behind. This allocation process is often opaque, driven by private deals, existing relationships, strategic investments. The result is a tiered system, a cognitive caste system, where the most privileged players get first and best access. At the top of this pyramid are the tech giants themselves: Microsoft, Google, Amazon, Meta. They place massive, multi-billion-dollar orders, often years in advance. This guarantees a steady supply to build cloud services and train proprietary models. The next tier, AI labs like OpenAI and Anthropic. Their partnerships bring preferential access to large GPU clusters, letting them rapidly train and update flagship models. At the bottom, smaller startups, university departments, nonprofits, independent developers. While the West sees a consolidation of power around a few corporate giants, a different strategy is emerging from China. Faced with US export controls on advanced chips and a desire for technological self-sufficiency, Chinese companies and research labs embrace an open-source approach to AI. Instead of building closed proprietary models like GPT-4, many Chinese entities are releasing powerful foundation models under permissive licenses. Anyone, anywhere in the world can download, study, modify, and use these models for free. This creates a powerful counter-narrative to the pay-to-play ecosystem of the West. By releasing high-quality open-source models, Chinese firms can rapidly build a global community of developers and users. This helps them gather feedback, improve their models, and establish their technology as a global standard. It puts immense pressure on Western companies that charge high prices. If a free, open-source model can achieve 90% of the performance, many will choose the cheaper and more flexible option, eroding incumbents' share. This strategic use of open source could lead to a more fragmented, competitive, and accessible AI landscape. Well, it's a big shift. One of the most significant concerns in the current AI landscape is the trend toward vertical integration. This is when a single company seeks to control every layer of the technology stack: silicon chips at the bottom, cloud data centers, foundation models, consumer-facing applications at the top. A company might design its own AI chips, use them to power its own cloud data centers, train its own proprietary foundation models on that infrastructure, and then integrate those models exclusively into its own suite of popular software, search engines, operating systems, office productivity tools. This creates a closed and self-reinforcing ecosystem that can be nearly impossible for competitors to penetrate. It can optimize its software to run best on its own hardware, making competing services appear slower or less effective. It can bundle its AI features with its other dominant products, forcing users to adopt its entire ecosystem to get access to a single tool. Antitrust regulators are beginning to take notice. So, yeah, that's a real concern. We are at a critical juncture in the development of artificial intelligence, a fork in the road, one path to corporate towers, the other to a diverse, community-led future. The path we are currently on leads toward a future where the most powerful technology is controlled by a handful of corporate giants. This concentration of power poses fundamental risks. Risk, innovation. Risk, economic fairness. Risk, the health of our democracies. When a few companies control the infrastructure of information, they can shape public discourse. They can pick economic winners and losers. They can operate with influence that rivals governments without the same public accountability. This is not an inevitable outcome, but avoiding it requires clear and decisive action. First, governments must reinvigorate antitrust enforcement for the 21st century. That means scrutinize partnerships between cloud providers and AI labs, block anti-competitive mergers, create rules against self-preferencing and exclusionary bundling, build public and open alternatives, invest in public compute and high-quality open-source models. The time to choose our path is now. So let's be deliberate.